Hello, everyone. Welcome to today's webinar. We're going to wait a little bit for everyone to join. Just a couple minutes. Thank you for your patience. While we wait for the rest of people to join the webinar, maybe it's a good moment to introduce the fact that we're going to share these resources with everyone. The webinar will be recorded and you'll receive a copy of this recording, as well as the template of the PowerPoint presentation and many resources such as documentation and other things we're going to be showing today. Also, feel free to ask any questions. There's a dedicated section for the questions, so we'll be answering those at the end of the presentation. Thank you. Just wait a couple more minutes. Well, great. I think we're good to go. Welcome to today's webinar. Today, we're going to be talking about how to structure efficiently a PV project from development to O&M. Today's speakers are myself. I'm a technical advisor at RatedPower. I've been here for almost 2 years, and I oversee the Brazilian and Iberian markets. And with us is Frederik Merz. Frederik, would you like to introduce yourself?
A classic mistake, forgot to hit the unmute button. Thank you very much for the introduction. Thank you very much for the introduction, Daniel. I'm Frederik Merz, co-founder and CEO of Amperecloud. I'm in the PV industry since over 10 years now, with focus in the topics of PV monitoring, operations and maintenance, and power plant control.
Perfect. Thank you, Frederik. And no worries, problems of the life, right? That's the also.
Yes, absolutely.
Perfect. So today is going to be a very interesting session. We're going to give you a little bit of tips and insights. There's even going to be a little bit of a short demonstration. But I think first, it's interesting to just give you a little bit of context since we're going to be talking about how to structure a PV project efficiently. So it'd be interesting to understand what the timeline of a PV project is. So let's start from the PV development. So when we look at a project, at a PV project, we can clearly differentiate different stages, right? The moment we start deciding that we want to build a project, then we start planning, then there's a more technical execution of this project, construction, and once the asset is built, we're ready to control it, monitor until the end of its life cycle, right? And if we take a more close look at this timeline, we can maybe distinguish something like this, right? We have a conception, pre-feasibility study that can cover from 3 to 6 months, feasibility study and permitting up to a year, right? Then we would be entering a stage of financing, contracting, detailed design, again, construction, commissioning, operation and maintenance, and decommissioning. What are some challenges that are involved in this development of PV projects, right? We all are part of this industry. We probably all know these problems very well, and these are just some of it's just the tip of the iceberg. But as we know, we find ourselves fighting against complex regulatory landscapes. We have to navigate permits, grid access, a lot of environmental assessments. It's a very manual process, right? It could be very time consuming. This generating all the documentation for the environmental assessments and for the permitting is something that takes a lot of time. And if we do it manually, there's an increased likelihood of human error. So here we just put together a brief description of these problems. And once we start entering more detailed phases in O&M, for example, we start facing other types of challenges, such as, for example, the prospecting challenges, difficulty in finding optimal sites, the information is limited and it's not always accessible in public. And managing the data is also something that's challenging, right? It's not always easy to find a way to efficiently handle all this ginormous volume of information. There's not always an integrated data management system across the industry. And it's definitely hard to keep track of the progress and the main KPIs with a good perspective, trying to make those data-driven decisions. In the end, all these kind of challenges and problems end up in delays, increased costs, inefficient use of resources, and in the end, well, missed opportunities for optimizing the performance of a PV project. If we take a closer look at the feasibility studies, and now we start entering the RatedPower territory, so to speak, feasibility study is the one that's going to determine if the renewable energy project is going to advance, gets that green light, but it needs to identify potential roadblocks in the beginning of the planning phase. And this would cover, for example, site selection, the assessment of the solar resource, the sizing of the system, selection of the equipment, of technology. Then we enter a more design stage, the solar plant layout, design, electrical design, and also we cover interconnection, grid, environmental impacts, project economics, and then the O&M phase. I'll let Frederik explain this part way better in the end, but construction and commissioning, operation and maintenance, and monitoring analysis. In the end, the goal here is to limit the project risk and address these issues early on. This will minimize the impacts, not only financial, but also in terms of time that we'll be putting into our project. And when identified, many critical design constraints can be overcome effectively with planning, avoiding going over budget or getting stalled. So how do we do this exactly? And that's why RatedPower and Amperecloud are here today to show you different solutions to approach these problems. And we'll start with RatedPower. RatedPower is the smartest way to design utility-scale solar PV plants. We're a cloud-based software that covers from siting to offtake, and not only performs the design of the layout of the PV plant, but we also do some basic engineering, and we cover the interconnection and the storage sides of things. So today, we're gonna give you a brief showcase of our tool. And I thought it would be cool to present a case study. For example, how can we find the best TCAC ratio to minimize the LCOE while comparing the results and deciding on the final design? The tools that we're going to use are the batch design simulation that we have is one of our functionalities in the tool, and the comparison tool. I'm going to present you with a project which location is in Almeria in Spain. We're using a PV module of a generic brand. It's a bifacial module of 610 watts. We're also going to be using a central inverter, and we're going to be implementing it in a single axis tracker configuration. So time to log in into the tool, and we'll give you a brief overview of RatedPower. Perfect. Now, what you're looking at is actually our software interface. We're inside a folder called Webinar Amperecloud. And here you can find different designs and different simulations within this project, right? The key and the philosophy of RatedPower is that we have no limit in the number of designs that we can perform, and we're going to take advantage of the speed and quick automation that the tool is going to provide us to perform as many scenarios as we want in order to try to optimize and generate a lot of output documentation for each of these scenarios. For example, I'm going to click here on one of these designs, and you'll see a brief overview and summary of not only the inputs, which are on this left-hand side, we also have a brief overview of the DWG, of the layout, and on the right side, we see, for example, the main KPIs, the main metrics and results of this simulation. The most important part is the documentation button. Every time we generate a design on RatedPower, we get this set of documents with over 400 pages of reports, spreadsheets such as the bill of quantities, and different drawings, always in different formats, allowing the user to implement this in their workflow. And since we're a worldwide software, in different languages as well. So this is the output section of our tool. And now that you've gained a little bit of context on RatedPower, let's actually start a design from scratch and solve the mystery that we presented earlier. I'm going to click on Start a Design. Now we access our design interface. And we have on the left-hand side again, all the set of inputs that we need to customize in order to customize the documentation and run the simulation, right? The only requirement is really to upload a site. We can perform this in many different strategies, uploading layers from a KML, from a DWG or a shapefile. And once we have a plant defined, such like this is a, actually it's interesting. I took an example that already exists. It's one of the first generation PV plants in Spain from 2008. And I thought it would be interesting to not try to replicate the layout, but using the same areas, understand how this project would look like today in 2024 with a tool like ours, right? So I brought some polygons here. And if I click on Run Design, I quickly gain in a matter of seconds already some results and documentation. The software is very intuitive. It presents you different colors that help you understand what's going on. In red, there are some removed by electrical configuration structures, and this has to do with the power requirements that we haven't set yet. So once you upload the location, you're able to run the design, but the idea is that in order to customize and get the maximum out of the tool, you need to fully customize not only the equipment, but also some layout and topography and the rest of the parameters, right? For example, here, I can quickly set flexibility in terms of the DC-AC ratio to try to maximize the capacity of this plant. And I can also group in low voltage the polygons. When I do so, with a click again, now we are maximizing the peak power of this plant. And you can see here that the total unused peak power is 0. So how do I now approach our goal here, which is to determine which DC-AC ratio is going to minimize our LCOE, right? In order to do so, I'm going to use the batch simulation. What you saw me do here was performing a single design, so I can change some of the parameters on the inputs and run the simulation. The idea now is to run multiple designs at the same time while just iterating across one of these variables, right? The pitch distance, the DC-AC ratio, or in the case of the fixed structure, that could be the tilt angle. Let's try this with the inverter, DC-AC ratio. I'm going to introduce 13 inverters in this plant. And I'm going to choose, for example, a minimum DC-AC ratio of 112 and a step of 003. When I refresh this table, I can generate all of these designs at the same time. And they start loading here. They will take seconds or a minute to complete. Since I don't want to waste time here, I already performed this simulation, and allow me to just go back to the project folder and show you what the results look like. If I select, for example, all of these simulations, I'm actually going to filter the ones that I performed with a batch design. I can quickly compare all of them. And this is the second part of the optimization. It's the comparison tool that empowers the user to quickly identify the optimal design. For example, if I arrange these designs in increasing LCOE, I notice that the design with a 1.2 DC-AC ratio is the optimal one in my case, given the constraints that I set in the design process, right? So quickly now I can, for example, keep on working on that design. I'm going to favorite, mark it as favorite. And when I go back to the project folder, I can clone it, edit, and keep working on that favorite design that I just reached. Another interesting thing that I thought I wanted to show you today, and we still have a couple minutes here, is the fact that we can, for example, include different steps in medio data. And this plays a huge role, right, after in the operation and maintenance of the PV plant and its performance. So For today's exercise, I uploaded different time steps. For example, we were using an hourly TMY, but we can also use a 15-minute, a 5-minute, and a 1-minute TMYs and run the simulations. Again, I already did this exercise just to show you the results. And here you can find, for example, the conclusions of this comparison. I'm going to arrange them in specific production. And as expected, the specific production decreases with a more fine time resolution because we gain more visibility on the clipping effects on the inverter side. So this is good news, and this empowers me to make decisions based on data and really customize and design my PV plant in the most efficient way. Maybe if I'm using 1-minute data, I have more information about those clipping losses, and I know now how to size better the DC-AC ratio and perform more batch simulations. In the end, you will get all this documentation, and the next step would be, for example, contacting Frederik and saying, hey, Frederik, this is the output of my PV plant. Are you ready to take it to the next level and create a digital copy of it? So I'm going to give Frederik the floor now, and we'll speak a little bit about operation and maintenance.
Absolutely. Thank you very much, Daniel, for the introduction and also for the really interesting demo. Yeah, I just thought for a second to bring it back to the timeline we've seen earlier, because we have now talked a lot about the planning phase of the power plant, and I would say when you are in the last stages of planning the power plant, it makes sense to think about operations and maintenance, because while it's just one entry here on this slide, it's basically a timeline that ranges from 25 to 40 years. So it might make some sense to look deeper into it. And also because the landscape in operations and maintenance is really diverse. So also today, I'm not going to showing you like a product demo, because if you are already keen with monitoring systems, you might have like a general idea how they look like. Some of you might be more on the planning side or the project side and might want to outsource operations and maintenance to service providers, which is also fine. So I'm gonna give you more high level visibility on what kind of challenges we see in the operations and maintenance sphere and how we at Amperecloud can help you. So let's go to the next slide. And so this is something here which is, I promise this is the nicest slide we're gonna bring today. No, just kidding. This is really the, let's say, the ugly truth that we really often encounter when we first talk with customers that have a really, let's say, a diverse history of, for example, mergers and acquisitions of power plants, of setting up different business units, integrating different monitoring platforms. And the thing that is resulting is shown here in the chart. So you see both the internal process landscape as well as the data landscape is super cluttered. And you have many breakpoints where you need to basically manually fetch data from one tool to another, or you need to train your employees on multiple monitoring platforms, on multiple ticket systems, just so they can fulfill their basic tasks on different sites that they have in their portfolio. And then additionally, there might be other systems you need to integrate as well, such as a CMMS, a BI system, an ERP system, where you need to transfer then manually data because there is no APIs. And this is something that we want to change. And how we're going to do that, you can see in the next slide. So we always sit together with our customers. Usually we do when we start with them, or even before we start and signing a contract, we sit together with them and map their processes. We take a look at what kind of data inputs do they have, like what sort of inverters are they using, what data loggers and power plant controllers, what sort of third-party data do they use, like market data, metering data, grid operator data. So what's kind of getting into the system, and we take a look at what needs to go out. What's like, how do they operate? Do they have an ERP system, CRMs, BIs, or what kind of reports do they need to provide to their customers, to their investors? And then we figure out how Amperecloud platform can help here. Because Amperecloud platform basically acts as a centralized data layer that lives below like the different applications. Amperecloud platform is also a monitoring system, and it's also a ticket system, and it's also a report system, but it provides you also with we call it the operating system of renewable energy. So it provides you with a data layer below. If we go to the next slide, we can see reporting as, for example, such a topic that's, I think it's always for the most of the operators that we are talking to, they have some sort of operating duties, reporting duties. So it could be an internal reporting between different business units. It can also be a reporting to their customers if they are a service provider to other customers in the field of O&M. Or it can be if you are an integrated power producer or an IPP, you have reporting duties to your investors or banks sometimes. And what we basically usually do is like we create a list of these stakeholders. We take a look at what kind of duties you have to report. And then we build, usually what we do is we build a real-time dashboard where you can give an access to at any given time to these stakeholders. And we make an automated reporting that is basically like a PDF file, or it can be an Excel file or whatever. We are super versatile when it comes to like which kind of formats you want the reporting in. And those are automatically generated like every month, every quarter, every year, and sent via email. Okay, next slide, please. Then we usually work on implementing on an intelligent alarm structure, because the problem is the power plants get bigger, you get more data nowadays, like you have, for example, string inverters with many MPPs, and still like additionally many monitoring of individual strings. So you have an exponential growth of components and alarms that these generate. And usually, if you are longer in the sphere of operating, we see at many teams what we call alarm fatigue. So the customers show us their existing monitoring system, and they have 1,000 alarms, 10,000 alarms that are just sitting there and are not getting like confirmed or closed or whatever. Because you can imagine, it's the same as if you have ever been to like vacation and you come back and your email inbox is showing like 100 unread emails or 600 or whatever. Then sometimes you might think, the lowest 500 I'm not even gonna bother with, because like who can handle all this? And this is something we want to stop with our intelligent alarm system. So we have an alarm structure that automatically detects the hierarchy of components. So one example is if you have, let's say, a transformer alarm because like a power switch has been cut, then usually in many alarm systems, you also get alarms for the individual strings that you are monitoring. But that doesn't make any sense, because you don't need to look at the DC side of your components if there is a problem in the AC side. So this is something where you have alarm suppression, and when that comes in handy. You have other cases, for example, if you have shading that affects, let's say, a few strings, let's say a few dozen strings, but not like on an inverter or transformer level. So then it makes sense to say, we have triggered 30 alarms, but they happen roughly at the same time and at the same like device level. So our system automatically groups them together because it says, we have 30 alarms, they look really similar. You just have to look at one of them, and then you can understand these whole alarms. So all of these features help to really, within the first 12 months, sometimes it even goes as fast as 1 or 3 months, you can set up a structure that helps you to to have really a healthy daily operating routine where at the end of the day there is no unconfirmed alarms open. All right, if we go to the next slide, this is also something that's really important if you are setting up your O&M portfolio. This is the so-called bathtub curve. It shows that there is some failures or some problems that happen at the beginning of a commissioning, like you commission the power plant and some fuse burns, for example, or you set up the monitoring and there's missing some data. Then you have the wear out failures. So after 10 or 20 years, there might be some like damages at the inverters. And then there's random constant failures. For example, if you like have like a hailstorm and hail hits your DC modules, then of course that can happen at any given time. And you need to anticipate these also when you set up your alarms. And so it makes sense to look always in the life cycle of the to the most relevant parts. So I've seen I have 2 questions here. Let me quickly take a look at these. So the first question is, what should be definitely automated in O&M and what's easy to automate in O&M? I would say the first and foremost thing that should be automated is the monitoring itself. There are a lot of customers that are still doing monitoring in a way that they click through every facility and they have a dashboard where they see every string, every inverter, and then they compare it and they see if something looks weird. And I think that shouldn't be done in a world where you can set up really nice and automated alarms. So this is one thing, and the other thing is definitely reporting. So we have customers that priorly to Amperecloud were having teams that were sitting there and they were just writing reports for just a few rather large power plants, and this is something that doesn't scale very well. All right, then there is another question. Can you give an example of setting up hierarchies in an alarm system? How can such a structure look like? Hierarchies you can imagine in terms of the power hierarchy of a power plant. So you have a grid connection point, a centralized one. Then you have multiple transformer stations. You might have between the grid connection point and transformer stations, you might have switching stations, and then you have inverters, and then you have MPPs, and then you have strings. And hierarchy always means something that's happening in the more upper part of the food chain should basically prevent any alarms in the lower parts of the food chain from happening, so you don't get spammed. All right, I hope that answers both of these questions. So
Thank you, Fred. Yeah.
Very
Thank
welcome.
you. I see our audience isn't shy today, and we have a lot of questions. I believe
Yeah.
uh, you wanted still to talk a little bit about the monitoring, right?
Yeah, I will talk a little bit about the monitoring, and maybe at the end we can see if there are some questions remaining. And also, of course, you can shoot us also any questions also afterwards via mail if we can't answer all of your questions. So yeah, and the one part is we really ask our customers to challenge the way that they do the monitoring. This is what I also meant with the automation of the manual monitoring. So we are encountering teams that are just used to this very manual kind of process where you skip through every screen every morning, every noon, every evening, and it takes hours basically. So you should start with these low-hanging fruits, and then once you are like your plans are getting more mature, your team is getting more mature, and you get used to the software, we should usually you should we recommend once per quarter. You can do that also together with our customer success and our solutions engineers. Um, Look together into your processes and figure out if there is still something that can be automated, where time can be saved, or where mistakes can be reduced, like the quality can be increased. And last but not least, if you're doing something regularly in Excel, that's usually the best, the first place to start, where you should think, maybe Excel isn't the right place to do PV monitoring or PV operations. All
No
right.
hard feelings,
So
Microsoft. We want
yeah,
our
no
lives
hard.
to be easier.
Absolutely. All right. Yeah, then that would be our presentation, and I think we can now. We have still some time for the Q&A session. I think there could be some questions for us, some questions for you guys, Daniel. So just look into that. We can look into
Of
that.
course. Maybe since you already took two, I think it's my turn, right? And that way
Okay.
I'll give you also a break. I see one question here that says how it is evaluated if the optimal design is a central or a string inverter. And that's a great question. Maybe today we didn't have time to deep dive into all of the parameters in the input section of PV design or rated power. But here we can, one of the things that you can input is exactly the inverter, the equipment. You can choose if you're going to be working with a central inverter or a string inverter. And we also provide you with a public database, a library of files. So this is very relevant. We keep it updated. As you can see, we have over 157 pages of inverters. And in the case the user wants to use a private file, you can also upload a PAN file or an OND. And once you change, for example, in the design to string inverter, I can now rerun the simulation and the software will take that into account on the layout. Going back to the questions, we have another one here regarding RatedPower. I believe it's asking, when estimating the cost, are you including the AC and DC cables? And this is, again, a great question, a topic that we didn't show on the tool. But when I ran these simulations and calculations of LCOE, one of the parameters that we input as well is the CapEx template. So here we're using a default template that we get from IRENA, from the International Renewables Energy Agency. And they give us an estimation of these values for the PV projects. In this section, you can also customize a CapEx template and of course, add entries for the DC and AC cables. So we have a lot of units here, and the software, what it does when calculating the financial analysis is crossing this information in the CapEx, the inputs that the user gives for the units you want to measure and their price. And we cross this information with the bill of quantities that we generate in the documentation. So that's how we calculate not only the CapEx, but the financial piece. I believe there's also a related question to these asking, how do we prepare for O&M here on the financial aspect on RatedPower? And I think it's very interesting because this is a new functionality we introduced here. And as you can see, our OpEx is more detailed now. You can distinguish between DC power, AC power, available area OpEx, and you can also give it an escalation factor, for example. We also have the opportunity to introduce the revenue, so a price for the sale of energy, and this could be, for example, variable across the year. And that's how we calculate some parameters such as the return on investment and some charts that you see here on the tool. So this, I think, really connects with the piece that Frederik was talking about. And yeah, thank you for your questions. Frederik, I'm not sure if you have any questions for you.
Let's see. I think there's one more. What are the challenges when streamlining data in a central system? So I think in order to answer this, we can skip to one slide again where we have this like map of the architecture, the chaotic one, the one before. And I think here we see basically the challenges. So if we are not on a greenfield setup, but it's more like a grown / legacy setup, we usually encounter something like this to begin with. And then we need to figure out which of these tools, platforms, solutions we should replace and which of them should stay and how we integrate with our solution. And for this also, it usually takes like we invest some time with our solutions consultants to look into that together with the customers and to figure out where it makes sense most to replace something and where the existing systems should stay. Like also we never try to, like of course we want to sell as much as possible, but we never try to convince someone to change something that is a working system. Okay, I hope that answers the question. So it's the short answer would be it depends.
Thank you, Frederik. I'm gonna go to the questions list. I'm not sure if we have any other question, but again, we invite everyone to also contact us through email after the session if there's anything pending. I'm just gonna review the list one more time.
Yeah, there's one more question for us, I think. What are the O&M differences between fixed tilt and single axis tracking systems? So from our perspective, there is not a lot of difference because from our perspective, it's just a few more data points and alarms basically. So usually our software is quite flexible when it comes to data streams. So we also have data streams from completely different systems than PV, like mechanical systems, on-site consumers, wind farms, etc. PP, it's not a problem. On the O&M side, I can imagine you have to be really knowledgeable about what kind of issues can arise with the tracking systems, and and see how to anticipate them and where to anticipate them.
Perfect. I also see here a very interesting question. It says, are you controlling, certifying the data on the OND files? Some manufacturers may have a very optimistic approach to improve the results from your software. That's actually a great question. I think it's also a concern, an overall concern in the industry, is the data in the PEN files, in the OND files, living up to the expectations that we set, right? And is this validated? And to answer your question, the way we build the library on RatedPower is directly from the manufacturer. So we trust that the manufacturers go through that exercise of validating their data. And I mean, from my point of view, it would be only of their interest that their users would then live up to the expectations they're indicated by a modeling tool like ours when using the data, right? I must confess that we sometimes see this validation on the label itself, on the files that we receive, it has a specific certifier stamp. Sometimes it doesn't come with that certification, but it's, I believe, an exercise that the manufacturers should perform before spreading their data across different modelers. That's why we also invite every user to upload their data and the equipment to their private database, so you can control what you're modeling and really certify it on your own, right? Well, thank you for the questions. I believe that's all. Just want to finalize with our contact information. If you have any hesitation, if you have any doubts, you want to talk about anything specifically that we covered here, we welcome anyone to get in touch with us. And we hope this session was interesting and just gave you a little bit of perspective on different solutions that can help you face the challenges in the industry. So thank you very much for your time and have a great day.
Thank you very much as well, and thanks for the chance to speak to you folks.
Of course, Frederik. Thank you so much for the collaboration. It was a pleasure, and see you next time.
Pleasure for us as well. Thank you very much.
Bye bye.